I wasn't searching for technological impossibilities when I opened those engineering journals. At first, the entries read like hundreds of others from the late 19th century. Columns of figures, sketched arches, water tables, ink faded into the margins by clerks who assumed their work would never be questioned, river projects, stone pylons, maintenance costs. The language was dry, procedural, almost indifferent. Then a phrase repeated in several volumes from 1879 began to stand out: elevating platforms, counterbalanced chambers, current-driven lifts. Not bridges, not ferries, something suspended between them. The sketches were small, tucked beside drawings of pier foundations, pulley housings half submerged beneath waterlines. No flourish, no bold declarations of innovation, just components treated as routine additions to civic infrastructure. Surveyors had initialed the corners. Municipal clerks had stamped approvals in red ink that had bled through the paper. Builders had penciled measurements where stone met river flow, adjustments that suggested experience rather than experiment. That ordinariness unsettled me more than grand claims ever could. Across several cities, across different watersheds, the proportions remained eerily consistent. Vertical shafts recessed into masonry, intake channels cut low against the current, gear housings sealed inside towers whose exterior profiles looked purely decorative to modern eyes. The journals never paused to explain why these features existed. They moved on to paving costs, timber shipments, labor disputes, as if lifting road decks above rivers by hydraulic force required no commentary at all. I traced those notes outward, from continental infrastructure programs narrowing toward a single crossing whose specifications exceeded anything attributed to ordinary 19th century bridgework. The stonework alone implied loads that should have required boilers or winches. None were listed. Architecture began to feel less like backdrop and more like testimony. What troubled me most was not what the journals recorded, but what modern catalogs did not. No museum plaques referenced such mechanisms. No civil histories celebrated them. The sketches survived, the towers remained, yet the function they implied had evaporated from memory. The first crack wasn't dramatic. It was administrative, ink on paper, numbers that didn't behave. And once I noticed that absence, I couldn't stop following it. The journals stopped being abstractions the moment I stood beside the river. What had once existed only as ink lines and faded annotations now rose in stone. Towers flanking the span like quiet sentinels that no modern plaque bothered to explain. Their faces were smoothed by a century of weather, but the geometry remained intact. Vertical recesses ran up their cores, narrow shafts sealed behind infill masonry that didn't quite match the surrounding. Blocks along the waterline, channels had been cut with deliberate angles, guiding current toward cavities hidden below the bridge deck. They were not decorative. Tool marks still traced the interior edges, where panels had once been removed and replaced. The stone worn in patterns that suggested repeated mechanical contact rather than erosion. Ledger fragments from the journals echoed in my head as I paced the base of the pylons. Intake housings, counter chambers, load bearings. River workers in the 19th century would have stood here, hauling stone and timber into place, adjusting flow gates whose outlines were now barely visible beneath later repairs. Engineers would have calculated stress tolerances from these very ledges, noting how water pressure could be redirected upward instead of allowed to rush freely beneath the span. None of it required spectacle. It required familiarity. That familiarity no longer existed. Measurements refused to settle into comfortable categories. The chambers were too tall for drainage culverts, too reinforced for simple inspection shafts. Iron anchor points had been set deep into the stone, aligned vertically, spaced as though to cradle massive platforms moving through the tower cores rather than decorative railings. The pylons were not merely supports for a roadway. They were housings, suspended systems. Standing there, I followed the current as it pressed against the cut channels, imagining gates sliding into place, turbines or wheels hidden behind stone, energy diverted upward instead of downstream. The bridge above felt heavier because of it, not physically, but conceptually, as though it were balanced on something no longer acknowledged. Ferries once crossed this river with ropes and pulleys. That much the histories proudly recorded. But ferries did not require shafts carved through granite. And as the water rushed past the foundations, I kept returning to the same question, one the stone itself seemed to ask without words. Why build so much when something simpler would have worked? Once the stone stopped feeling ornamental, the numbers took over. I went back to the journals with different eyes, no longer skimming margins, but reconstructing systems line by line. Flow rates, gate diameters, head pressure, measured against seasonal river depths. The notation was economical, stripped of flourish, yet it implied forces far greater than the calm surfaces of these crossings suggested. Sluice, apertures, angled upstream. Differential chambers layered beneath the pylons. Cylindrical housings sketched where water could spin before being redirected upward into vertical shafts. Turbines, or something close enough to make the distinction uncomfortable. Mathematicians had penciled ratios beside those drawings, long columns of figures, correcting one another, refining torque and resistance until the margins filled with crossed-out assumptions. Patent clerks had stamped approval marks in tidy ink, dates aligned within weeks across several sites. City inspectors initialed the corners, the bureaucratic equivalent of a shrug. What the calculations implied refused to sit quietly. Even conservative estimates suggested platforms weighing many tons could have been lifted steadily by current alone. No boilers, no coal stockpiles, no exhaust systems recorded anywhere in municipal inventories. The flow of water beneath the bridge, when translated through those ratios, became something else entirely, a continuous engine. I traced those equations back to the pylons, matching intake diameters to carved channels, shaft widths to recessed towers. The correspondence was too precise to dismiss as coincidence. And yet nowhere in patent registries, council minutes, or engineering treatises from the era did I find debates about installing river-powered elevators into public bridges. No controversies, no celebrations, no explanations. Only the structures, only the math, and an expanding gap between what 19th century hands had calculated and what 20th century archives were willing to remember. The drawings did not announce themselves as revolutionary. They were stored where municipal records usually went to rest, inside thin folders labeled with bridge names that no longer raised eyebrows, river crossings, reinforcement schedules, span repairs. Only when I unfolded the brittle sheets did the problem become obvious. Vertical shafts ran through the bridge decks themselves, not beside them, not added later, but integrated into the original load-bearing geometry. Lift cages aligned with the pylons I had already visited. Intake tunnels matched the stone channels cut into the riverbanks. Someone had designed these systems from the start. The stamps were what unsettled me most. Routine approvals, filing dates spaced weeks apart, no experimental markers, no budget warnings, no extraordinary designations. Draftsmen had signed their initials in careful loops, the kind learned in technical schools, while archivists later slotted the plans into shelves beside flood barriers and resurfacing proposals. Across different towns, hundreds of miles apart, the motifs repeated, identical pulley housings, matching shaft diameters, gear ratios penciled into corners in the same shorthand. I overlaid copies on a table and watched lines converge where they should not have. Separate projects behaved like iterations of a single blueprint. The contradiction hardened when I searched for correspondence. No tender requests, no council debates about cost overruns, no letters arguing feasibility, just the drawings, complete and calm, depicting synchronized platforms rising through bridge spans using nothing but the redirected current. Ordinary, on paper, unacceptable in hindsight. What remained was a silence shaped exactly like explanation. Paperwork is supposed to be dull in a reassuring way. Budgets leave trails. So do tax levies, council appropriations, reimbursement requests for materials hauled from distant quarries. I expected the ledgers to slow the story down, to replace speculation with columns of certainty. Instead, they sharpened the problem. Stone purchases were itemized to the penny. Labor gangs were tallied by week. Timber shipments appeared and reappeared in tidy rows. What never surfaced were categories for turbines, gearing assemblies, pressure chambers, or lifting platforms implied by the drawings I had already seen. The pages grew more meticulous, precisely where the machines should have demanded the most explanation. Treasurers initialed approvals, auditors checked margins, clerks copied totals into bound volumes thick with municipal routine. Their handwriting changed from town to town, but the pattern did not. Infrastructure of improbable complexity passed through accounting systems as though it consisted only of blocks and mortar. I followed the emissions across jurisdictions. Different rivers, different councils, the same quiet gaps. Blueprints had shown how these systems worked. The ledgers showed how they vanished, not through fire or catastrophe, through bookkeeping, and the realization settled slowly, the way unease does when repetition replaces accident. Once I began lining the sites up on a map, coincidence stopped being persuasive. The bridges were scattered across river systems that had no reason to share contractors, let alone experimental infrastructure. Different states, different municipal charters, separate quarry suppliers whose invoices traveled along unrelated rail lines. And yet the stone told the same story every time. Intake tunnels cut at identical gradients, vertical shafts spaced within inches of one another, reinforcement ribs hidden behind facing blocks arranged in matching intervals, as though masons hundreds of miles apart had been following a template they never questioned. Shipping logs confirmed the pattern. Limestone from separate pits arrived in quantities that mirrored one another almost exactly during the same months of 1879. Timber beams of uncommon thickness were ordered in bursts that appeared synchronized. Across jurisdictions that officially had no collaborative planning committees, regional planners left faint signatures in approval stamps and routing codes. Subtle bureaucratic fingerprints that reappeared where they should not. The omissions in the ledgers now made a different kind of sense. They were not isolated clerical failures. They were uniform. I traced the dates again. Slower this time, watching as refurbishments, expansions, and unexplained structural reinforcements clustered inside a narrow band of months. Spring to autumn, river levels high enough to matter, water strong enough to drive something far heavier than barges. No correspondence described shared engineering conferences. No public tenders linked the towns. No newspaper columns marveled at synchronized upgrades across half a continent. And yet the stonework agreed with itself. Across every crossing, the river had been asked to perform the same task. Across every archive, the paperwork pretended it had not. The absence became louder than anything the stone could say. I walked the perimeter of each site, looking for what should have remained behind if heavy lifting machinery had ever occupied these towers. Boiler foundations, ash pits, chimney flues, blackened by decades of combustion. Steam lines embedded in masonry, the way 19th century factories left scars in brickwork, none appeared. The pylons rose cleanly from riverbanks, without soot staining their upper courses. Underground chambers contained no furnace housings. Renovation records catalogued drainage repairs and repointing work, but never the removal of engines. Tool inventories from municipal depots offered another quiet contradiction. Crates listed sprockets, pinion gears, valve assemblies, chain links thick enough to bruise a hand when lifted. What they did not list were pistons, pressure cylinders, coal augers, or fuel storage fittings. The components belonged to transmission systems rather than generation plants. Water, it seemed, had been expected to do all the work. I returned to the hydraulic ratios and recalculated with conservative assumptions, reducing flow rates, lowering seasonal averages, accounting for sediment drag. Even then, the numbers insisted that a steady river could raise platforms repeatedly without pause, provided its force was channeled with sufficient precision. That possibility felt less like speculation than oversight. Contemporary engineers, judging by their notes, treated the arrangement as infrastructure. No debates about revolutionary energy sources, no commemorative plaques, no editorials celebrating triumph over physics. Later generations, confronted by sealed shafts and decorative towers, reclassified what they could not immediately operate, and in doing so inherited systems they no longer recognized as systems at all. Once the question of power was suspended in the air, another problem asserted itself. Machines of this scale do not persist through guesswork. Any system capable of lifting loaded platforms above a fast river would have required calibration, inspection cycles, replacement tolerances, failure protocols. Valves seize, bearings erode, channels clog with silt, gear teeth deform under load. Even the most robust 19th century mechanisms demanded constant human attention. Yet the archival trail thinned precisely where instruction should have accumulated. I searched for operating handbooks, training circulars, municipal safety notices, correspondence between engineers and bridge superintendents. What survived were fragments, marginal notes about lubrication intervals, receipts for bronze bushings, an order for replacement sluice shutters, recorded without explanation of their function. Where grooves cut into stone floors traced repeated movement, but the pages that should have described that movement were absent. Refurbishment reports from the early 20th century deepened the unease. Contractors catalogued cracked masonry and corroded rails, but described elevator chambers as obsolete cavities. Ornamental relics sealed off during modernization. The language implied not dismantlement, but misunderstanding. Spaces once worked daily had become architectural curiosities. It was not destruction that erased the system, it was the loss of those who knew how to use it. By the time the bridges entered preservation registers, the language surrounding them had shifted. Restoration files from the interwar period no longer spoke of intake tunnels or lift chambers. They catalogued surface stone, railings, decorative pylons. Channels once flushed by current were filled with rubble and capped behind masonry plates. Shafts were drained, sealed, then rebranded as inspection voids or aesthetic recesses. The paperwork was calm, procedural, confident in its own redefinitions. What unsettled me was not that systems were altered, cities modernized, infrastructure is simplified. What lingered was how consistently purpose was replaced by ornament. Plaques approved by municipal heritage boards praised proportions, symmetry, civic pride. Permit applications described the same spaces I had traced through blueprints as scenic curiosities. Hydraulic vocabulary disappeared without being argued against. It was simply omitted. A margin note from one architect paused long enough to register friction. The shaft was unnecessary to present function. The sentence read, followed by an ellipsis before the next line resumed with masonry specifications. Tour scripts from later decades completed the transformation. Guides spoke of monumental stonework, triumphs of 19th century aesthetics, romantic silhouettes against water. No mention of vertical platforms, no reference to pressure chambers. The mechanisms were gone from speech before they vanished from stone. The bridges had not changed. What surrounded them had. By the end of the search, the river itself had become the only constant witness. Journals reduced the systems to footnotes. Blueprints treated them as routine. Ledgers accounted for stone but not engines. Restoration campaigns drained their chambers and renamed their voids. Each layer of record changed the vocabulary, never pausing long enough to argue with what had come before. What remained in the present were pylons heavy with water stains, sealed shafts aligned with current, intake mouths disguised as decorative recesses. Structures that continued to obey hydraulic logic, even after their purpose, had been erased from speech. The pattern was no longer confined to a single crossing or a single year. It traced a method, a way of building that assumed rivers could do more than carry boats. I kept returning to the same restraint in 19th century documents. No astonishment, no technical debate preserved in council minutes, no public celebration of breakthrough. Only the tone of utilities being installed, maintained, then quietly forgotten. What else, I wondered, had been carried by water and later reclassified as stonework? What other systems were once considered ordinary? And whether what now appears impossible is only that way because the context that made it sensible has been allowed to disappear.